So, what are the odds? I mean, really, have you ever wondered if luck is just, total chaos or if there's some kind of hidden order to it all? Well, today we're going to untangle the math behind chance and see just how predictable the unpredictable can be.
Let's start with the classic coin flip, right? It's supposed to be a perfect 50-50 shot. But think about it. If you flip a coin 10 times, you might get 7 heads and only 3 tails. That doesn't feel very 50-50, does it? And that little feeling, that little gap, that's actually our way into a much bigger idea about how probability really works.
See, it turns out that probability has, well, it's kind of got two very different personalities. You've got the probability of what actually happens when we try something out in the real world, and then you've got the probability of what should happen in a perfect, logical universe.
So on one side, you have what we call experimental probability. This is all about getting your hands dirty, Just seeing what happens. And on the other side, that's theoretical probability. That's what the math says should happen. No experiments needed. These two, they're the main characters in our story today.
All right, let's start with our first character, experimental probability, and see how this thing works in practice. You can think of this one as the detective of the probability world. It's all about gathering clues from what's already happened.
And the idea behind it is actually pretty simple. You just count how many times something happened, and then you divide that by the total number of times you tried. That's it. It's hands-on, it can get a little messy, and it is based entirely on real-world observation. Okay, let's look at a real-world example to make this super clear. Imagine a pizza shop manager who tracked 197 slice orders during a busy lunch rush. The data from that experiment? Well, it shows that pepperoni was the clear favorite, with a whopping 98 orders. So this data gives us a really clear experimental probability. You can see there's about a 50% chance the next customer is going to order pepperoni, and maybe a 26% chance they'll get vegetarian. Now, if you're the manager, this is gold. You can use this info to prep for tomorrow's rush.
But here's the crucial point. What if the manager had only tracked, say, 10 customers? The results could be totally skewed, right? Maybe the first 3 people all ordered Hawaiian. So experimental probability is super powerful, but it's only as good as the amount of data you have.
Okay, so now let's meet our second character, theoretical probability. If the last one was the detective, this one is the architect. It creates this perfect blueprint of every single possibility before anything even happens. The thing with theoretical probability is we don't actually need to run an experiment. We just have to logically map out every single thing that could possibly happen. That's called the sample space. And then we just count up the outcomes we're interested in. It's all on paper.
And this table right here, this is a perfect sample space for rolling 2 dice. It lays out all 36 possible combinations. It's a flawless blueprint of every single thing that can happen.
And when we use that blueprint, we can calculate the exact theoretical odds. You can see there are 6 different ways to roll a 7, which makes it the most likely sum. But there's only one way to get a 2, snake eyes, and only one way to roll a 12. The math is just clean, perfect.
So we have reality versus theory. The messy, real-world results from our experiments versus the clean, perfect logic of math. So what happens when we force them to meet? Where do these two worlds collide?
Well, this quote right here is the key that unlocks everything. It says that a few flips or rolls are going to be chaotic, totally uncertain. But when you do it thousands and thousands of times, a beautiful, predictable pattern starts to emerge from the noise. I mean, talk about dedication. This statistician, Carl Pearson, he actually did this back in the early 1900s. He sat there and tossed a coin 24,000 times. And his result? 50.05% heads. I mean, that is unbelievably close to the perfect 50% theoretical probability. He basically proved that with enough data, messy reality starts to look just like perfect theory.
Now, lucky for us, we don't have to flip a coin 24,000 times to see this in action. We can use a simulation to watch this convergence happen right before our eyes. So, let's roll some dice.
Okay, after just 10 rolls, our experimental results are all over the place. I mean, look at it. This looks nothing like that neat bell-shaped curve that the theory predicts. It's just pure chaos.
All right, let's fast forward to 100 rolls. Okay. A pattern is definitely starting to take shape. You can kind of see that peak forming in the middle, right around the number 7, just like the theory said it would. But, it's still pretty jagged, pretty rough around the edges.
But now, let's jump all the way to 10,000 trials. And wow, just look at that. It's beautiful, isn't it? The experimental data has completely smoothed out into an almost perfect match of the theoretical probabilities. The chaos has literally turned into order.
So what we're seeing is this incredibly powerful idea called the law of large numbers. This is the bridge that connects the real world and the world of theory. What it tells us is that while individual events are totally unpredictable, the long-term behavior of random events is actually incredibly predictable. Small samples are random. Large samples reveal the pattern.
Now, just for a second, it's worth mentioning one more type of probability, one that we all use every single day: subjective probability. This isn't based on big experiments or perfect math. It's based on our gut feelings, our intuition. When you say, "I'm 99% certain I aced that test," that's your intuition talking, not a spreadsheet.
So, from the randomness of a few coin flips to the amazing predictability of thousands of dice rolls, probability is just this powerful tool for making sense of the world. So think about it. The next time you see a weather forecast giving a 30% chance of rain, or you hear about the odds of a medical test, ask yourself, is that experimental, theoretical, or maybe even a little bit subjective? It makes you wonder, doesn't it? What really are the odds?